when the plan becomes ePlan. So why do I use ePlan? 6 reasons why. Why do I design in 3D? Let's start a small design very quickly. Okay, let's go to ePlan. Here, of course, in the tutorials, you will see something interesting when you watch in the ePlan section. There's something called the Cogineer. The Cogineer is a configurator that allows me to just simply create a new project if I want to. This new project is based, like any other project, off of a ZW9 template. I'll call it, let's say here, the Cogineer. Let's call it BT3 project 1 or 2021. There we go. So here's my configuration. I can technically choose a couple of different options or not, right? This is really me not choosing something. And I just hit the generate button. What it does in a few seconds, really a few seconds, it creates a project, nothing else than what you would do in ePlan, create new project using the ZW9, the template, which already defines what symbols I want to use, what plot frame I want to use, what forms I wish to use. Everything is set in there. And then, of course, it places macros. Macros that I can show you if you want to, that are predefined and that either come in or not, depending on the option I just picked. Here is my generated page. So technically, my Cogineer project is now generated. And you can see in this case, we have a few schematic pages, 1, 2, 3, and 4 schematic pages that got generated. Each of these, let's say, schematic pages all came from that option here that I picked. If I would have picked a different option, I would have had a different schematic, obviously, with more or less objects. Inside ePlan, every component, every symbol has a device tag, but also has a part number. So, of course, the next step is to evaluate out of this project here, how much space do I need? So I found an interesting way to calculate this. If you actually take each object, each component that is inside your panel, you calculate the width and height. Technically, the width and height, if I take these and I eliminate the mm for the millimeters, you will get a plain odd number, which is millimeters. And what this gives me is basically an area for each component. If I multiply and sum up that area by a certain value, I can see what is my average when I square down that area. What is my best square that actually will do this? Now, since we're in North America, let's take this value here and divide it by 25.4, just to see what kind of value we have. So we have a 24 inch by 24 inch, which would be the optimized space for my panel. So from this point on, what I do is I check out what part number is nice to be used. So technically, of course, I open here the Rittal configuration system, the RICS. I pick whichever panel I wish to use. These are the panel types that they can actually sell me. Then I go inside here, the width, and I decide and filter down to either 24 or 30 inch. On the height, I'll do exactly the same thing. I'll go with 24, 28, and 30. And here I can see which one I want to use. Maybe this one is the best one I want. The 1077, it's actually 8 inches deep. Let's try it out and see if it works out. So technically, let's go back to ePlan, open our layout, and check out in this particular Cogineer layout. Here we have a layout. This layout already has huge panels. I don't need that big. This will represent my A1 panel. So basically, this is my main panel. I can actually put a describer here if I have multiple panels. And I usually also associate this with my so-called mounting location A1, which represents in my schematics my panel. So here, what I will do, I will eliminate those ones and I will reinsert an enclosure, the one I just picked there, which was the part number 1077. Of course, I can continue the filter to complete the part number entirely, and I will get that AX enclosure that I was looking for. So here, place the enclosure. You will see an EPLAN. This is a perfect digital twin of the enclosure, not very deep. And inside this, we have the housing, we have the mounting panel, the door. I'm interested in the front view here of the mounting panel. And I already have a couple of drawn, if you want here, pre-drawn rails and ducts I can use. I'll just place them here. They're perfectly aligned with that 30 by 30. That's a typical one I have. I'm going to try it out. Okay, so it's basically try and error. We're in 3D, so we do our best, right? So let's say we want to start with our terminals. We can say, okay, our entry terminal, in this case, TB. You can see all my components. So I'm going to pick the TB1. I'm going to place them in one row and just place them here on the first one. That's where my power is. TB1 was my power. TB2 is actually a different one. TB2 is everything that goes out to sensors and push buttons, whatever. You can see it goes very quickly and it disappears from my list. So now let's concentrate maybe on the 120 portion. 120, I have a circuit breaker primary side, secondary side. I just call them like that, CBP, CBS. And those ones, yeah, let's place them right up there. You can see there's a connection designator. I could place them there if I want to, but hey, this is probably better because you can see there's a link here that goes through the routing. So you can actually think about the routing up front very quickly. So these are these two. They will pretty much feed the transformer here. That's cool. Then we have a power supply that is not far away from this. So we can place the power supply right there. Give it a little bit of space for cooling. Then we have, of course, two big, huge drives. This is on the other opposite side. So these two drives, they may or may not fit. I'm not sure. Let's try them out. Yeah, they do fit here. So they have wires that go all over the place. So, I mean, we might as well put them in the biggest space we have. Remember, these drives, I will have to probably move a little bit around because when we look at the details, they have some mounting clearance. And right now, I'm really at the edge here. So this is probably better off if I move the whole thing a little bit down like this. That's a little bit better like that. And it gives it the perfect area to breathe as recommended by the manufacturer. So this one here, I'm not too sure if I want to keep it like that. Let's see if I really need that space or if I can move everything around. Maybe I can use it right out of the box. So these are breakers. These breakers, where do they connect? Let's see. Once you pull in the first one, you can see, yeah, it's probably better if I place them there, but we can see that I'll have to move my stuff around because this is not big enough, okay? I turned off voluntarily the collision check because it would have not allowed me placing them. I prefer going a little bit faster like I just did here so that I can pretty much place my components. So where's the best one here? This one, is it better there? Is it better there? Well, you know what? I think it's actually better if I place it there, right? So it's a lot closer to wherever the wires are. Interesting, because I would have not placed it there. This is, what is that component? This is actually a more complex component. I don't have enough room to place it. This is my PLC, and I really have to think, do I want to place it? If I place it up there, I get a lot of wires going down. Maybe what I want to do is place something new down here. It might be a little bit more efficient. Same as this one here. This one could be actually this one. Place it there. It's cool. Place it like that. Place it like that. These are two. And these overloads, one by one, I will have to connect. These are very special ones because when you look at them, let me just zoom in and you'll see these are really nice components, but they are actually to be hooked up right away on this spot here. So what I'm doing is I'm just picking the OLR snapping or mounting point, and you can see that automatically it rotates in the right direction. It's really cool. And really, even if I look at it from a 3D perspective, you will see it actually hooks up right away where it actually should. And I think it's really, we'll leave them as they are. So here we don't need any extra DIN rail. I think the spacing is good. If we move everything down a little bit, that will all work nicely. So what I'm going to do here is I'm going to add some more mounting rails. So mounting rails are just part numbers like this. You can get them from Phoenix Contact, from Rittal, from, you know, you can even take some generic one if you don't really care who is providing them. And this is how we actually placed them in the first place. We just went and placed them like that. So drag and drop. When you have one like this and you want to duplicate it, you can just duplicate it and it actually duplicates that easy, and you just come and place it here. So you can evaluate a little bit the spacing. You can even go and specify a very specific spacing where you say, okay, I want to go minus 75 millimeters from, let's say, the center of that DIN rail. Okay, that's one way you can do it. You can even change your handle if you're more comfortable, right? You can actually change the handle to the other side and say, let's go center here, 75 millimeters, like this, boom. And you just basically decided that this duct is exactly 75 millimeters from the center of that DIN rail. So of course, coming back to the PLC device we had earlier, let's see if it actually fits this time. If I just drag and drop it, it should most likely fit because we had seen it a little bit earlier, and it fits nicely. Let's put it right in the center. We have enough space, right? We can always move other things around if we want to later. And now what we'll do is we'll actually reevaluate the position of some of these objects and see if we can actually optimize some of these things. This is a very small component, I guess. I can just place it here or place it here. This one, let's see, does it actually fit in there? It would actually fit. This is the interesting thing. Okay, so let's just fit it in there. Why not? You know, and there we go. So what else do we have? We have these guys here that actually will have to be connected somewhere like this. There we go. So we have everything that goes inside the panel done. Let's now move our objects in the position, you know, this one, let's move it as far down as we can. So maybe there. So this one, and this one, we can now, of course, move all together. So it's just, you know, moving it down a little bit. And we said, let's move it as far as we can. And here you have to decide if you want to go with the collision check. And this is actually a good timing to turn it on because this is my final placement. So when I place these objects or I move these objects, I want to make sure that it's not colliding in anything, right? So let's see, zoom in. So this was here. There we go. This is perfect. It gives me enough space for these objects to actually be linked up. It's all nice and dandy. You know what? These three, I would probably leave that up there completely free. Since I have some of them, I would probably move those ones right over here and just keep them aside on this side because it's already some power. So we got now all our components placed. We still have some room. This is cool. And we can now have ePlan evaluate the routing. So when we do the routing, ePlan looks for the best possible routing or wire way that actually will link up these objects based on what is in the schematics. We can look it up in a 3D fashion if we want to. You can see here it's all nice, cute, connected, nicely connected as it should. And this actually calculates the length of the wires. So if we go back here to my ePlan, I just go in here. I now have no reports, but I will be generating in one single menu here all the reports I need to fabricate the panel. And I'll show you very quickly, I'll do a quick rundown of what this generates to help the manufacturing of the panel. This is our specialty. Rittal and ePlan, we really specialize on this. How can we read information from our schematics, from our panel layout, put it together for each individual step of the fabrication of my panel? What we did with Rittal together is we evaluated and we looked at several panel builders. We looked at how they did things, how they did them manually, and we came up with interesting solutions. The number one solution, of course, the number one thing that everyone wants, we start with, is the kitting list. We start by picking up the parts. Here we go. Here is a device tag, a part number, even a picture. So it makes it easy to find the part, put it in the bin. Second thing is the cutting of the ducts and the rails. Remember, we had all these ducts and rails. We adapted, we changed the length, we added. Well, here is a perfect cut sheet. So basically, you can go now to the grinder, grind down these ducts and rails exactly to the perfect length. You can see here millimeters and inches, whatever you prefer. We even have a machine at Rittal that actually can help you cut these automatically. Then comes the step of preparing the backplate with holes. These are all the holes we need for the DIN rails. If I go one step further, I now have another one that actually will show you here the assembled components on the backplate. Now, of course, when I look at this, there are different ways. This is a nice picture, very honest 3D picture, but the data is hard to read. So I change it a little bit. We have different views. This is actually my preferred view where I can read the different device tags. I still have to clean up here and there sometimes because I have too many devices in one spot. So I can always take a device and say, okay, let's move that text out of the way because this rail, which I call power, right, should probably be more on that side, so it's a little bit easier to see all these device tags. This one here, maybe you want to make it a little bit bigger. Instead of 5 millimeters, you may want to show it in 10 millimeter size, whatever, right? You can actually show this. And here are all the parts. This is individually every single part. We even calculate here the different power dissipation. We add them up to actually see if we need some climate system, either some fans or climate systems that Rittal sells. So this is part of the evaluation, but helping the guys to place the components. And when I say place the components, I also think about assembly of the terminals. So here we have different ways to show you what we have in terms of terminals, what is connected to each terminal, but also how is every terminal strip built, with each part number, clip fixes, and everything else. So that actually helps the electrician build and assemble the terminals. And of course, the labels. Yet the labels, I can do even quicker than this. I can take this, just jump over to the Project Complete tool. Here I have my wire markers, cable markers, device markers. They're all marked up, the ones I want. And I throw this out automatically. I'll get back to it. It's starting in the background, so I don't even have to worry about it. And I'll show you also another very, very important step is actually everything that handles the wires. So we have here a detailed wire list, and you can see that the detailed wire list even comes with a length. Every wire now has a length. That means I can actually pump that information into a wire station. So here the wire fabrication, the Rittal terminal WT is an example where we can pre-cut the wires, crimp the wires with a crimper, and put the labels on. So if you're wondering where the labels come, well, here they are. Let me just not update this. Here are the labels. All labels are pre-printed. So I can now have this label put on the right wire. If you sort these two lists exactly the same way, you can use the wire station. This will probably cut a quarter of your production time in your panel. Good. This now can also be shared to every single electrician by moving it up to the ePulse. So I'm not going to go into that detail, but the ePulse is a very nice cloud, a cloud where we actually share the panels, whichever panel we have with an organization. Here, let's say I take the EPLAN CA organization. Take this, move up to the eView free. It's free actually to use, actually, yeah. Everyone can actually see it. Everyone can see the projects that were uploaded here. And to upload this project entirely with the 3D, with everything, really, with everything, even links, even details about the parts, the bill of material, every report that you saw gets updated here. So this was basically ePlan creating a project in about 20 minutes, me even talking. Probably if I wouldn't be talking, I could do it in even less. This is of course a standard project. This is something we can pump through the Cogineer, but the idea is there and you understand how ePlan actually works. So this is now loading of course on the ePulse. I invite you to go and check out here through ePlan. You can see if I call it up here, eView, ePulse, just to give you an idea of how it looks like. Once you logged on, this is for everyone out there, electricians, customers, everyone. The idea is to share your project in one single spot, in one clouded area, and there's only one version of the project. Even better than this, we give you some redlining capabilities. So if I take one of these projects, this is one that I did a little bit earlier. Let me just open it. You can see everything that I showed you, like the kitting list and everything that I just showed you as a report. But I can also see the schematics I was talking about earlier. This is a very similar schematic. This is one of the components we opened, and you can see here on the right-hand side all the details related to that component. You can even jump to the data portal and read a little bit more about the component itself, the part number itself, because the data portal is something that you can look at any given time out there on the web. So you can see here we have some accessories even that are proposed by the manufacturer. It's really cool. Now, on top of all this, you get the 3D. So this is not exactly the project that I loaded up just earlier. I used a different panel, so you will see that the panel is a little bit different on this one. But we even see a 3D that can be uploaded. There we go. This is my 3D, a bit even more tight than the one we saw earlier. I can even check inside, outside. I can see if it actually fits. I can see everything. So this is exactly, these are the same components, just fitted in a different panel. There we go.